let's bring in a coefficient. Notice I have a radical in the denominator, the square root of 5. So we know we have an issue that needs to be addressed here. The conjugate of 3 root 5 plus 3 is going to be 3 root 5 minus 3. That second term changing signs. One thing worth noting, when we were dealing with monomials, we didn't have to worry about the coefficient in front of the radical. When we're dealing with binomials, we do, because we want those inside and outside terms to cancel when we FOIL. So when you're talking about conjugates, we want both terms, and just that second one changes sign. Nothing else gets omitted, nothing else gets removed. So we found our conjugate. Let's go ahead and multiply by 1. So there's our original expression. And multiplying this thing by 1, well, 1 is the same as 3 root 5 minus 3 over 3 root 5 minus 3. Because any number divided by itself is just 1. So hopefully we kind of see the flow here. We know what's about to happen. In the numerator, there's a distributive property. And in the denominator, there's a FOIL. But a FOIL where at least something good comes out of it. The inside and outside terms should cancel. We should be left with a denominator that is a whole number, something where there are no more radicals. It's time for the hard part, step 4. Actually doing a bit of arithmetic here. We have the 2 in the numerator times a 3 root 5. So because that 2 is a whole number, it gets multiplied by the 3, the coefficient. So that will be a 6 root 5. And we also have a 2 times negative 3. Positive times a negative will be negative. So that will give us a negative 6. In the denominator, this is our FOIL problem. First, outside, inside, last. So I'll do those first in green. I've got a 3 root 5 times 3 root 5. I'm going to go ahead and work this out in 2 steps so you can see where all the numbers are coming from. 3 times 3, the coefficients, that's going to be a 9. And then root 5 times root 5 is root 25. We'll simplify that once I get that whole denominator written out. Outside terms, 3 root 5 and negative 3. That's going to be a negative 9 root 5. Again, positive times a negative is negative. 3 times 3 gave us the 9. The inside terms, 3 and 3 root 5 is going to give us a positive 9 root 5. So that's all going to work out exactly the way we expect it to. And then our last 2 terms, 3 and negative 3. 3 times negative 3 is negative 9. So as we're looking at that denominator, again, I'm going to do this in 2 steps so we can see where everything's coming from. Note my inside and outside terms do cancel the way we want them to. And then that 9 root 25 is the same as 5. So we actually have a 9 times 5. 9 times 5 is 45. So those 2 short steps there for simplifying. 45 and negative 9, those are like terms. 45 minus 9. Go ahead and extend the page here. So we're going to have that 6 root 5 minus 6 in the numerator, 45 minus 9, which is 36 in the denominator, and that takes care of our step 4, that multiplication part. Step 5, just like last time, if you recognize this right away, rockin'. You've got 2 6's in the numerator and a 36 in the denominator. Those all have a common factor, and that common factor is just 6. So if you notice that one, rock it. You can factor that 6 out of the numerator, leaving us with a root 5 minus 1. And 6 goes into 36 6 times. So we can reduce this whole thing by 6. It's not quite as nice a final answer as the previous example, but this leaves us with a root 5 minus 1 over 6. Which is nicer than the 6 root 5 minus 6 over 36 we started with. So always be on the lookout, see if there is anything that can be simplified. In this case, it did work out nicely in that 6 is a factor of 36. In the previous example, it just happened to be even numbers. We were able to reduce by 2. Take a look, see if there's a common factor of 3. Sometimes there's a common factor of 5. Those are the really the ones that happen the most often.